Hello, Tommy Gartland here again. So we've looked at in the previous videos at how to control a LED, turn a LED on and off, and we've also looked at how to monitor a switch, monitor the voltage on a pin that's being controlled by a switch. And now things are getting really interesting where we're going to try and control a servo. Now a servo is just basically a motor with some gears actually included. So gears, as you know, increase the torque or increase the drive at the expense of speed. So it's a trade-off between torque and speed. So in the servo case, it's not a continuous rotation servo. In other words, it doesn't continuously rotate in this case. It's a positional servo. So we can position this tab here, if you like, at an angle between 0 degrees and 180 degrees. And this is ideal for controlling the joints on the robot arm. So we're going to need 4 servos eventually, one for the shoulder, one for the upper arm, one for the lower arm, and one for the claw. And all those movements are restricted to within a certain range, and it may not be we may not be able to go the full range 0 to 180 degrees with the robot arm. So that's something we'll have to look at when we insert these servos into the robot arm. You're going to have to test it yourselves and determine what the actual range for each joint is, because as I said, it may not be the full range, and we have to be careful. Now the motors are actually quite sort of power hungry compared to an LED. In other words, they would take a lot of current, and if you take too much current because the gears got stuck or there was too much friction, for example, then the voltage would drop, and if the voltage was to drop, then it may end up resetting the system. So we have to be a little bit careful. You would hear, maybe when we have USB connected, you might hear the USB, you know, the noise that arrives when you disconnect or connect. It will be the same thing, so just be a little bit careful with this. We also have three leads here on the servo. We have ground, which is the brown, and I think these are the same servos that you will end up with. So brown is ground, the red is power. So generally black is for ground, brown in this case, red is generally for power, 5 volts. So that's your power. Obviously it needs power, but then we need to be able to control the position of it, and that's where the signal wire comes in. In this case here it's orange. Now we've made up specifically a PCB to allow us to easily connect a number of servos and joysticks to the Arduino Uno. And Robert in the college has actually designed this PCB, and I'll show you the schematic in a moment. But the PCB is designed by Dundalk IT, and then it sits down on top of the Arduino board. Be very careful when you're inserting the pins of the PCB onto the Arduino board. There's only really one way it fits in, but be careful that all the pins are lined up, and push it down gently on both sides, you know, so that you don't bend the pins. Okay, and the same when you're taking it out, ease it out one side at a time slightly, just sort of wiggle it out if you like, and not to just pull it too much on one side. You may be in danger of damaging the pins. And you can see we've got a LED on this PCB, which is also connected to pin 13 underneath. The only thing is now we won't be able to see the power light, the LED or the TX or RX, but we have our LED here on the PCB. There are switches here, but you won't have the switches or pot probably on the PCB that you get. These were just originally for a sort of a plan B that we had, but I don't think we need plan B now. Now there was one issue. This is, you can see here there's a connector on the servo, and the plan is that this connector would just insert onto a connector on the PCB, which would take the power and ground from the Arduino Uno board, and also then connect to one of the pins on Arduino Uno, and that's all done through wires on the PCB, and then connected into the pins on the Arduino Uno board. The Arduino Uno board is actually sitting down here underneath. You can see how it's connected in underneath. Okay. Unfortunately, when we designed the board, we made a little mistake, and this happens in engineering. And you can see here we've got power on the right, we've got ground on the left, and signal in the middle. But if you look at the connector, it's ground and power and signal. So the connector just can't be put in onto this connector on the PCB at the moment. It doesn't just insert in. So we had to make a version 2 of the PCB, and we're waiting for that at the moment. And hopefully when that arrives, you'll be able to just come along with your connector and connect it directly to the terminals here on the PCB, making sure to orientate it the correct way around, so that the ground wire here, the ground, goes to ground on the terminal. Okay, so maybe just double check that. So now, how do I know which pin on the Arduino Uno my signal wire goes to? So you can see I've just sort of put 3 wires here to actually just, you know, for the moment to run the wires to the power, ground, and the signal in the middle. This is the shoulder, this says lower arm, this says upper arm, and this says claw. So we have a schematic here that was done as part of that PCB development. You can see here's our connectors, our 3 pins, and the problem is that we can see that the signal wire is in the middle, whereas with the connector, the actual physical connector, it should be on one side or the other, with ground, power, and then the signal. But you can see the upper arm, the lower arm, the shoulder, and the claw, they're the names used. And if you go across here, this is sort of the Arduino Uno, and you can see the shoulder is going to pin 5. The upper arm is going to pin 6, isn't it? The upper arm is pin 9, the lower arm is pin 6, and the claw is pin 3. So we make a connection we sort of infer the connection by using the same names. So shoulder here, and shoulder here as well. Here and here. Okay, so we use the shoulder, just for testing one servo, we'll use the shoulder connector, and you can see that the shoulder is connected to pin 5. What else do we have on this PCB? Well, we have over here, we have connectors for the joysticks. So effectively, what you will have to connect up is your 4 servos to your lower arm, upper arm, shoulder and claw, making sure, as I said, when we have the correct PCB, that you orientate the connectors the right way around. So the ground here, this black brown cable, or the dark cable, ground, goes to the ground pin, and everything else should be okay then. You just put in the connector. And we'll see here when it comes to the servo, or to the joystick, there's 5 wires on the joystick, and we'll talk about that when we come to it. So then we want a little program to actually control this, and this is where Arduino really comes into its own, because it includes sort of, libraries. Libraries are sort of libraries of functions, so blocks of code that we can use to very quickly create a prototype program. Now the first thing I've done is, you can see that I've defined pin names here: shoulder pin, upper arm pin, lower arm pin, claw pin. So I've looked at my schematic and I said, okay, the shoulder arm by that PCB is going to, shoulder pin is connected to pin 5. That's the one we're going to use here. And you can look at the schematic and you can see the upper arm is pin 9, the lower arm pin is 6, and the claw pin will be pin 3 eventually. I'm going to go up in steps, so we're going to change the angle of the servo. It can be any number between 0 and 180. So I've got a byte, a variable, to hold that value. Shoulder, I've called it shoulder underscore pos, which means position, shoulder position, and it's 0. So it's at 0 degrees there at the moment. And I'm going to go up in steps of 30 degrees. So you could go up in steps of 1. You can change this if you want to go up in steps of 10 or 20 or 10, but I've at the moment just gone up in steps of 30. Now here's where Arduino, as I said, comes in it comes into its own, in that we can include something called servo.h. And if you go to Arduino reference, say libraries, there should be a library here for servos. And say it's the Uno we're using. I should have checked this earlier. Oh. Yeah, sorry, so you go to libraries. I've gone down here to servo. I mean, this is just to show you that this information is available. And you can see that it's object oriented, so there's various functions associated with this library: attach, write, read, attach, detach. So there's where I'm getting the information from, if you like. So first of all, I've included this servo library. I'm creating a servo object called shoulder. So I can create, eventually we're going to have 4 servos. So we'll have 4 servo objects. We'll have shoulder, upper arm, lower arm, and claw. Okay, so we need these functions, a set of functions for each one of these servos. And shoulder.attach, I'm basically saying what pin is connected to this servo. So this particular one that I've created in the software, shoulder. So shoulder.attach, we've created a servo object called shoulder, and we're attaching this shoulder pin to that object. Okay, and to control the angle, we just go shoulder.write. So shoulder.attach to associate a pin with this particular shoulder servo object, and shoulder.write to change the angle. And this number can be anything between 0 and 180. Okay, but be careful, when you're going to the full range, that, it's not overstretching, or it's under too much strain, or taking too much power, which might cause the system to reset. And I've put in a 10-second delay, and this is in the setup function. So you can see I just attached the pin to that shoulder object, positioned it at 90 degrees, waiting for 10 seconds, and saying shoulder servo position at 90 degrees. And this is one of the things you may have to do with all the servos, so a separate program to do that before you actually, while you're assembling the actual robot arm. So to position all the servos in a known position, 90 degrees, position the robot arm joints at a known position, approximately in the center of the range, and then insert the tabs onto the servos and into the robot arm. So Peter will explain more about that when he's assembling the robot arm. Here I'm introducing another thing. I've mentioned it before, the for loop. Now the loop function is an infinite loop, but the for is sort of like a finite loop. And what it basically, there's three parts to what's inside the round brackets, which is the control part of it. We start at a value 0. We have a test as long as the shoulder position is less than or equal to 180, because that's the limit. And then every time we go around the loop, we increase the shoulder position by this step. So we go, shoulder position is the old shoulder position plus the step, plus the angled step. In this case, it's 30 degrees. I'm going to print the shoulder position message, and then I'm going to print the actual shoulder position, whatever value it has. It'd be 0. So it'll go 0, 30, 60, 90, 120, 150, 180. And when it gets to more than 180, then it'll exit the for loop, go back round, come back round the infinite while loop, and then do it all over again. So I suppose the key thing here, we could have done this maybe without a for, but this is showing you how to use a for loop, a finite loop. We print the shoulder position, we print the message degrees, and print lin, remember print, we'll print these on the same line, but print lin now, we'll print degrees and then enter, we'll go on to the next line. And remember, I have to actually write that shoulder position to the servo, and then I put a 5-second delay. Okay, so let's see it actually working first of all. I'm going to connect up the power. It's already loaded, so I'll put the camera on. Here, I'm going to connect the power up. So there you can see it's in position, maybe you can't, but there you can now hopefully. It's in position 90 for 10 seconds. Now it's gone all the way to 0. Starts at 0. After 5 seconds it goes to 30. Another 5 seconds, go to 60. Then it'll go to 90. And at the same time, we could be actually showing the serial monitor. So I'm started all over again, sorry. When I run the serial monitor, it's like hitting a reset. Okay, it took a little moment there. I must have another delay built in. So shoulder servo positioned at 90. Shoulder position is equal to 0 degrees. My messages are coming out after my position, so I need to go back and have a look at this and debug it. Hold on 1 second. Okay, so I just noticed my messages were coming out after I was positioning, so I've removed my position message up here, so this should work a little bit better now. So we'll go Tools, Serial Monitor, and that'll reset it. We'll close that, sorry. We'll go Tools, Serial Monitor. And if we look at the camera now at the same time, you can see now it's at 90 degrees. After 10 seconds, it goes all the way around to 0 degrees. And then every 5 seconds it changes by 30 degrees. 30, 60. So here we are, we're going around this loop, 30, 60, 90, 120, 150. It gets to 180. It'll go 180, then it'll wait 5 seconds and it'll go all the way back round to 0. So once it gets to 180, it exits its for loop, goes back around and starts at 0 again. Okay, so that's it. That's an introduction to the servo. It's a small introduction to the Dundalk PCB for this particular project as well. If you want, you can actually go off and maybe put in more lines of code here just to position it and put a delay between each time. You could shoulder right dot position 10 degrees, delay shoulder right dot, shoulder dot right 50 degrees, and put in a small delay each time, and you'd see it going to those various positions. So it's very, very convenient to be able to control this servo using the Arduino servo library. Okay, so I hope you found that interesting, and this is going to be used, and we're getting to the stage where we'll be sort of hopefully building up the robot arm soon, and we'll see you soon in the next video. Okay, so thanks for listening. Bye now.